start looking at some ideas of how do volumes change when we start changing linear dimensions here, okay? So, volunteer to read my essential question for modeling with volume here today. What are we trying to answer here? All right, Annika, roll, kid.
How can you use the mass and volume of an object to describe the density of an object?
Okay, so we're going to talk about mass, and then we're going to talk about volume of an object to describe the density of an object. So we're talking about this idea of density. Last section we were talking about really the amount of people per area, but today what we're going to kind of talk about here, kids, is we're going to talk about the amount of mass something has, mass per unit volume, basically. Okay, so goals for the day. We're going to use volume formulas to find densities, and we're also going to use volume formulas to solve some problems related to density. All right, so let's make sure we understand our vocab first. Density again today. I'm just going to put some formulas up here today because really this is going to be here. But your density is going to equal a certain mass per unit volume. Okay, we kind of know what density is. What's mass? The amount of matter in the figure, right? Isn't that what they taught you in science class? The amount of matter. So they might say the mass sometimes is like 22 kilograms or something like that. All right. Yes.
So like mass is like.
Mass is kind of like weight of an object. Okay. Not the same as weight, but kind of like weight. All right. Because weights change relative to what, kids? And you've learned this in science. Do you weigh the same on the moon as you do on Earth?
Gravity.
Gravity changes your what? Weight. I've always said, if I'm going to lose weight, guess where I'm going? Going to the moon. Okay? So, density is just going to be mass per unit volume. And an example might be the density of something might be 3 kilograms per cubic meter, something like that. Okay? That's an example of a density. For every 1 cubic meter you have, it might be 3 kilograms. Okay? All right, volume here, kids. Things to remember. Volume. All right, you guys told me. Let's put a definition in our own words. The volume of something might be the amount to take to fill a 3D object up. Okay, it's the amount of space it takes up, in other words. Okay, so I like it this way. It's the amount of space taken by what kind of an object? Taken by 3D object. Okay? It's the amount of space taken by a 3D object. But it's also the amount that maybe you think about containers, like your cups or your cans or anything like that. It's basically how much does it take to completely fill the inside of that house. Okay? So it's like how much something holds. How much an object holds. Okay. All right, and now you all know what a square root is, right? Okay, square root. Square root is just taking, and then we just need to remember this, because we're going to apply this prior knowledge to what we're doing today. Square root of some number, like I don't know.
16.
All right, 16. What would that equal? 4. Okay. All right. Some people might get a little more technical and say, you know what, it could be positive 4, or it might also be what else? Negative 4. Okay. Let me just show of hands real quickly. Are you okay with the density formula for volumes today? What's our formula for it again? Mass per unit volume. Okay, so we're going to be talking about almost like a weight and then how much space that's taking up. We're going to be comparing those two quantities, all right? Volume, we know what that is. Are you comfortable with our definitions that we put up, kids? Okay, and then square root, we should all know how to work that, okay? All right, I want to get in and look at an example quickly in this dynamic classroom, so give me a second to load this while you guys are making sure you have everything down there. All right, let's look at a quick exploration together, see if we can't talk our way through this and then use those ideas to progress through this today. Did that go? Doesn't look like it, did it? There we go. All right. Just want to look right here. Quick little exploration right here, kids. Can you guys read that okay back there? Or do I need to full page that for you? Is that better? Okay, real quickly. Exploration here for us. Finding densities, okay? Let's just kind of talk the first one because I'm going to tell you, we'll look at more of these examples as we move, but right here, kids, again, what's the definition of density?
Mass over volume.
Okay, your density is going to be a mass over volume. All right, I'm going to write this right off to the side here. So right up here, it says work with a partner. It says approximate the volume of each object whose mass is given and find the mass per unit volume or density. Okay, let's just talk part A right here. All right. What kind of an object are we working with there? Brick. Okay. All right. I laid a lot of those when I played basketball in high school. Okay. Bricklayer is my nickname. If there was a players' weekend for basketball on the back of my jersey, it would have said bricklayer.
Why?
Anybody know what the basketball terminology is behind that right there? If you miss a shot horribly or throw it up there kind of hard, do you know what they call that shot? It's like throwing a brick up there instead of basketball. Okay. All right. What's the mass of this quickly? What's the mass of this brick?
Oh, 2.2.
2.3 kilograms, okay? I would like to find the density. How many kilograms per cubic, it looks like, centimeter here. How are you going to find the volume of a rectangular prism as that shape is for that brick? Anybody know that formula? We know the volume formula for rectangular prism. We should. Okay, if you don't know, that's okay. Because I've done a nice thing here, all right? Went into Wisconsin and I got some things the other day. Take a look at your notes on the very back page, would you, kids? Ooh. Oh. All right. Even though it says Wisconsin, we'll let it go by. All right. There's a reference sheet for all your formulas back there that we're probably going to be using. Okay. We're looking for a volume here, so all your volume formulas are going to be right in here. Okay. What's the volume? Doesn't the brick kind of look like this rectangular prism right here, kids? What's your volume formula according to this? Length times width times height. This little sheet's kind of a nice one to have. I would encourage you to have this out probably for the rest of the chapter because you're going to want to know these formulas, all right? So let's go back to this exploration right here, kids. So what's the mass of this again? 2.3 kilograms. All right, so we know we're trying to find the density of this. I know my density is going to equal my mass. How am I going to find the volume of that now, kiddos?
20 times 10 times 5.
You bet. The volume is just simply going to be 20 times 10 times
We're
5.
writing this down, right?
Yep. Well, you don't have to write this
Oh,
down.
okay.
No, don't worry about this. Okay. So what's the mass again, kids? 2.3 kilograms. And then your volume would be 20 centimeters by 10 centimeters by 5.7 centimeters. Now listen carefully on this, kids. When you do densities, it is very, very important that if you're looking for an object of a figure, all of your dimensions are measured with the same unit. In other words, if I have centimeters here and centimeters here and centimeters here for length, width, and height, that's a good thing. Are these all listed in the same unit here, here, and here? They are. Sometimes they might get kind of tricky and say, well, the height right here is 12 inches. The width here is 10 inches. And then they might all of a sudden go throw in this length of 2 feet. You have inches, inches, and then what? Feet. Can I proceed on that, or do you need to do something differently? You're going to have to change feet to inches. So maybe make a note right here on your notes. I I'm going to go back to the volume part up there. Make sure for volume right here, let's put it on the first page, I think. Right up here. Let's make a general note maybe right here with volume in this box. Make sure all, make sure all lengths have a same unit. If you start just looking at the numbers and you don't even take the units into consideration, things are going to get screwed up. So make sure before you find a volume that all of those units have the same unit to them. All those measurements have the same unit. Okay? All right, let's go back to that. Well, quickly then, kids, tell me. What is 20 times 10 times 5.7? Anybody know that? $1,140. Okay, so the way I'm going to find the density then, and what unit is density measured in up here? Kilograms. This 1,140 is not centimeters anymore, but it's really, what kind of centimeter, kids? Yeah, we're talking cubic units now. Volume's going to be a cubic unit. And then to get your density, you're just simply going to divide that out, okay? Where are my chemistry people at? Anybody got chemistry? What's another name for cubic centimeter?
Oh, I don't know.
Does your can on that say something like a certain number of milliliters? Like maybe 400 and something?
Oh, 473.
443 milliliters. 443 milliliters is the same as 443 cubic centimeters. I ever tell you I really wanted to be a science teacher instead of a math teacher?
Why were you back?
I don't know, because I was better at math than I was at science, but I like science more than I liked math. That doesn't make any sense, does it? I like science more, but I was better at what? That's weird, isn't it? Okay. What's this divide out to be? 2.3 divided by 1140. Big number or small number?
0.002.
Louder, Jaden.
0.002.
002 kilograms per what, kids?
Cubic centimeters. I don't know.
Okay. Yep. 0.002 kilograms per cubic centimeter. Cubic centimeter, big or small, kids?
Big, small.
Which is it?
Small.
Pretty small. You guys know dice that you play with, right? That's probably 2 cubic centimeters right there. So about half of a die would be 1 cubic centimeter. All right. Okay, so I think we get the idea. What I really want to hammer home today is what's your formula for density, kids? What per what?
Mass of volume.
Mass per unit volume. Okay, so let's get out of this and get into the examples right here. All right, example 1 right here. Here we go. Now again, if you're not sure about a formula, where do I want you to start looking at now? Back up, okay? All right, I need someone to read that first one for me.
The density of water is 1,000 kilograms per cubic meter. Find the mass of 1 cubic foot of water. Use the fact that 1 foot equals 0.3048 meters.
Okay, very good. So we know right here, what do we know in this right here, kids?
The density is 1,000. Mass is 1.
Okay, so the density of water is 1,000 kilograms per.
Cubic meter.
Okay, so I'm going to write this down right here. My density of water is going to equal 1,000 kilograms for every cubic meter. Okay? We need to find the mass of one what, kids? A cubic foot of water, okay? So here's the deal. I'm gonna draw something up here as best I can. Maybe you want to do the same. And if you don't draw it, that's fine. But I'm gonna pull this up here. We got a shape involved up here. What are we trying to find the mass of, kids?
One cubic foot of water.
Okay, so I'm going to put a cube up here quickly. Oh, shoot. Okay, do you like my cube? Is it okay? It looks a little weird up here to me for some reason. Okay, but that's what it is. There's my cube, all right? And on my cube, kids, we need to find the mass of what?
1 cubic foot of water.
Okay, a cubic foot of water. Let's see. A cube is basically a prism here, right? Okay, so let's call this 1 foot. My length, or my width is 1 foot, and my height is 1 foot. Okay. I'll give you some time to sketch a cube. You want me to show you the best way to sketch a cube here, kids? Do this. Make a square here. Make the same size square kind of behind it like this. And then just connect your lines. Okay? That's the best way to do it. A square and connect your lines, all right? Okay, here's the deal. What we know up here, guys, is the density of water is 1,000 kilograms per cubic meters, right? But how many cubic meters are we talking right here when we talk about density? This is really how many cubic meters the way I've written this. Would you agree with that? Would you agree with that? Okay. Well, here's the deal. We know then if I have 1 cubic meter of water, it weighs 1,000 kilograms. We want to know how many kilograms there are in a cubic foot. Now it says right here, use this idea that says, oh, by the way, 1 foot is how much in meters, kids?
0.3046.
0.3048 meters, right? All right, so what we're going to do here is this, kids. What I could do with this cubic foot down here is change each foot to how many meters then?
0.3.
Exactly. So what I'm going to do is this. I'm going to change this is really the same as 0.3408 feet here. I'm sorry, meters. Okay. This is the same as 0.3408 meters. And what's the height also going to be, kids?
0.35.
Okay. So here's the deal. What we need to know then is this. 1 cubic foot, we would love to be able to turn that into cubic meters. Know how many cubic meters that is? Well, if this is 1 cubic foot, 1 times 1 times 1 is that 1 cubic foot. But if I want to turn this into cubic meters, what could I multiply together now, kids? How do you find the volume of this cube? Let's do that. So let me get a calculator. Length times width times height. So I'm going to go 0.3408. And we're going to times this by itself how many times? So question,
It's
kids.
3048.
Did I write that wrong? I did. Okay, so these should be 3048s here. All right, very good. Thank you. I get in a hurry sometimes, and I don't pay attention to detail, so that's why I keep you guys around. Who caught that? Who did?
Lexi and Annika.
Oh, thank you. Okay, so we're going to go not 3408, but we're going to multiply these 3 times. So I'm going to go 0.3048 times. Gosh darn this thing. What do I get for a value, kids?
0.02.
0.0283. Let's go 0.0283 because they went 4 places on that dimension. We'll go 0.0283 on our new value. So what this is saying, kids, is this. When we multiply this out, this is really saying that 1 cubic foot was equal to how many cubic meters again, kids?
0.0283.
Okay. So here's what we're going to do. What we know right here is the density of water is 1,000 kilograms per cubic meter. We wanted to find the number of kilograms per cubic foot. So in order to do that for a cubic foot, if we knew this density, we had to change this volume of cubic feet into what, kids?
Meters.
Cubic meters. So now what we're going to do to solve this, we're just going to simply set up a proportion. It says for every 1,000 kilograms you have for every 1 cubic meter, well, we're looking for the mass. We don't know how much this weighs. This is unknown. We don't know the mass. So I'm going to put M up here for mass. But we do know that the cubic foot is now how many cubic meters? The cubic meters are in that.
0.0283.
Going to be very important when we set proportions up. If I'm comparing kilograms to cubic meters on the left, you better be comparing kilograms to cubic meters on the right. Okay, units need to match in this section. If they don't match, you're going to have all kinds of problems. So that's why we chose to turn 1 cubic foot into what, kids?
0.028.
Cubic meters. Okay, so isn't that just a proportion to solve? 1,000 times 0.0283 divide 1? Well, if I do that, this isn't multiplying by 1,000 the same effect as moving a decimal how many places to the right?
1, 2, 3.
Okay, so how many kilograms would that be if I move the decimal 3 to the right?
280.
No, 28.3, and then 28.3 divided by 1. So we get M is equal to 28.3. What unit would this be for an unknown mass up here? Kilograms. Okay. 28.3 kilograms there, all right? Yep. That's a tough problem. And the only thing that makes it tough is they gave you a density for kilograms per cubic meter. And then they said, oh, by the way, what's 1 cubic foot? So we've got to turn that cubic foot into a cubic what, kids? What did you turn that cubic foot into?
0.02 meter squared. Cubic meter.
There you go. Very good. All right, it's early. It's early. You got there. Yeah, we have to change that so that we've got that in cubic meters for a volume. If you start with a volume in cubic meters, you've got to make sure that what you're looking for is going to have the same kind of volume unit to it as well. So we had to change all that, all right? Okay, let's take a look next page. Do you have what you need right here? So what's the mass here again, kids? 28.3 kilograms in that 1 cubic foot. By the way, anybody know how many pounds are in a kilogram?
5.
Give you an idea of this? 2.2. Okay? Take this answer times 2.2 for me. Okay, you see so they call it about 62.3. The tiles that are out in the hallway there, right? That's 1 foot by 1 foot square. So if you build up 1 foot all the way around there, can you imagine a cube that's 1 square foot, or I'm sorry, 1 cubic foot? Okay, if it filled that full of water, it would weigh 62.3 pounds. Okay? No wonder farmers are so tough. They're always moving stuff around in big buckets and stuff like that. Okay? I have a question. If you have a bathtub and you fill it full of water, which is definitely more than a cubic foot, how much weight is on that floor then? A lot. If 1 cubic foot is 62.4 pounds, oofda, that's a lot. Okay? Let's get through example 2 and then take a time out for the rest of the day. Sound like a plan?
Yep.
Tree trunk has a height of about what, kids? 18 meters, and it has a base diameter of what?
Half a meter.
Okay, now we've all lived and we've all seen trees, and we know that tree trunks are typically what shape? All right, so right up here, tree trunk, we're going to assume we're dealing with what kind of a shape then?
Cylinder.
Yep, I'm going to write that down right here. Assume cylinder. So we're probably going to need to know the volume formula for what, kids? Okay, so I'm going to write this idea down again. We are going to use a formula that density is equal to a mass per unit what?
Right.
Cubic value, which is volume, right? Good. All right, so I have that formula written down here. Now right here, guys, the wood has a density of how much?
550.
What do we have to find?
Mass.
Okay, so I'm going to highlight this right here. We have to find the mass. We have to find this. Whoops, I don't want to use red on red. That's kind of dumb. How about this? Ooh, it's Christmassy. How many days till Christmas, kids? Anybody know? Okay.
Months.
How about Siri knows? What do they call the Android person that talks? I always used to call her Iris.
It's like, it starts with a C, I think.
Does it?
It's like current.
Really?
Yeah.
I call it Iris because that's Siri backwards. Okay, here's the density. I'm going to plug in what value for density, kids?
550.
All right, 550. Is anybody checking the number of days for Christmas yet for me? Anybody? Okay, density, 550. I'm going to plug that in. 550 kilograms per cubic meter. We have to find the mass. We don't know that. Okay? In order to solve for an unknown, we've got to know at least 2 of the 3. That's the deal. Doesn't specifically come out and say the volume, but you assume the what, kids?
Percent.
Yeah.
119.
Thank you, 119. All right. I've been a good boy. 2019 Chevys will be out then. Silverado, red, Z71. You guys have any extra money laying around? Okay. Cylinders here, kids. Let's go look at this sheet. What's the volume formula for a cylinder?
Base times.
Base times height. We're going to add to this right here. Okay. I don't really like this way they wrote this, so we're going to add another formula to this. So a right cylinder is also the same as pi r squared times your height. Okay. I think that that's the one that you should put in there for volume. Okay. So on that last sheet where you get a cylinder in there, that top row, volumes of base times the height, at the area of the base, guys, the area of this base is a circle right here. And the pi r squared is the area of that circle down here, and then times your height. So I want you to jot that down in there, right? So let's go back to this right here. We're going to have pi, since the volume is a cylinder, we're going to have for volume pi times my radius squared. What is the radius in this, kids? It says a base diameter of 0.5 meters. So how about a radius then? Be 0.25, right? So I'm going to use my formula for volume of a cylinder down here. So my radius is going to be half the diameter, so 0.25 meters squared, times the height, which is what, kids? I think we do, don't we? The trunk of a tree has a height of what?
18.
Okay. Hey, quick question. Before I move on this, after I've plugged values in, check the values they gave for you, or the dimensions they gave for you on this tree trunk. Are they a match? Are the units a match? They're both in what?
Meters.
Okay. So I need somebody to calculate for me a little bit. I've got 550 is equal to the mass that we're looking for over the volume. somebody want to punch this up? 0.25 to the second power times 18 times pi.
3.53.
3.53. Okay. Anybody else get 3.53? Okay, so 3.53. Okay, I'm going to put the 550 over 1. Do I have enough information to solve for my mass there, kids?
Yes.
All right.
Wait, 1,943.
1,943, you said, Jaden?
Yeah.
Point.
86.
Okay. Let's see, we were looking for a mass. So do I want kilograms per cubic meter? Do I want kilograms or do I want cubic meter? We're looking for a mass here. Mass is kind of like a weight, so which one will be like a weight? We're looking for mass. The number of kilograms per cubic meter or kilograms per cubic meter. So mass would be measured in what unit? Kilograms, you bet. Okay. Kids, I think that's a good place to stop right there. I'm going to let you know, I'm going to send another online out to you today, so be checking on that. And we'll finish up. We have like, what, we have about 2 or 3 more examples left, and then tomorrow I'll give you some time to work on some things, okay? Questions at all? Going once, twice. All right. Very good.